Today we are working on Lesson 9, Writing Addition and Subtraction Expressions. So in example 1 in our classwork, it asks us to create a bar diagram to show 3 plus 5. Another way to say that would be a tape diagram. So we know if we were going to use a tape diagram to show 3 plus 5, we would make first 3 boxes, and then we would make 5 boxes. So we would show 3 plus 5. And we can put a darker line to separate our 3 and our 5 boxes. And then it asks us, how would this look if you were asked to show 5 plus 3? Well, we would start out with 5 boxes. Again, we would show that darker line to separate, then add 3 boxes. And it would look like this. And asks, are these two expressions equivalent? And we would say yes. We know that because we learned about the commutative property in Lesson 8. 3 plus 5 equals 8, and 5 plus 3 equals 8. So they are both equivalent because they both would come up with a sum of 8. And then it says, how can we show, for example, 2, a number increased by 2? So this is where our variables come in and where we really need to look at the language they're using. Increased by 2. So if it's a number increased by 2, it's going to look like this. A plus 2. So A is my variable. A represents a number, whatever that number might be. You could use any variable. I just chose A. Remember, a variable is a letter that replaces or represents a number. A plus 2, because increased by means I'm adding. So A plus 2. Or 2 plus A. Can you prove this using a model? If so, draw the model. So if I was going to use a tape diagram or bar diagram like we just saw, then this first part would be my A. Again, I'm not sure what that is equal to. I would have to separate that out once I found out. But then this would be my 2. So A plus 2 would look like this. If I was going to do 2 plus A, then I would start out with 2 bars. Again, do that darker black line to separate, and this would represent A. So this would be 2 plus A. So again, remember, this is an A, not a 9. Sometimes I make it look like a 9, but it's a variable that represents a number. So let's turn the page and look at the next example. Example 3 says, write an expression to show the sum of M and K. So we should know that this word sum means that we're doing adding. So if we want to see to write an expression to show the sum of M and K, we would either write M plus K or we would write K plus M. Which property can be used in examples 1 through 3 to show that both expressions given are equivalent? And we talked about that when we did example 1, and that would be the commutative property of addition. Commutative property of addition says that it doesn't matter what order you add in, you're still going to come up with the same answer or the same sum. Let's look at example 4 for some subtraction examples. It says, how can we show 10 minus 6? So draw a bar diagram to model this expression. So again, we're looking at a tape diagram. Well, first I'm going to start out with 10 in my tape diagram, 10 squares, because I know that I'm doing 10 minus 6. So I need to have 10 in my tape diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to make a tape diagram of 10. Well, if I want to show 10 minus 6, I know this whole diagram equals 10. I'm going to shade the 6 that I'm subtracting. So I'm just going to use lines to shade my 6. So these 6 would be the subtraction, 10 minus 6. What expression would represent this model? 10 minus 6. Could we also use 6 minus 10? Think about that question. Could we also use 6 minus 10? Hopefully you're saying no. We could not use 6 minus 10. There is not a commutative property of subtraction. So if we started with 6 and took 10 away, we can do that because we've learned about negative numbers, but we would not come up with the same answer as if we have 10 and took 6 away. So no, if we started with 6 and took 10 away, the models would not match. We would not have the same answer. So there is no commutative property of subtraction. Example 5. How can we write an expression to show 3 less than a number? So this is where we really have to pay attention to the vocabulary that they're giving us. So we want to show 3 less than a number. When we see this a number, that means we know there's definitely going to be a variable, okay? So if we don't know what that variable is, we're going to use n, because remember we can use any letter as our variable. There's not a specific letter that we have to use if we get to choose. So it says start by drawing a diagram to model the subtraction. Are we taking away from the 3 or the unknown number? So this says 3 less than a number. What are we taking away from? Right, we're taking away from the unknown number. So we're going to say we are taking away from the unknown number. And then if we want a bar diagram for that, it would look like this. Just kind of make a diagram like this. We're going to put a 3 and shade it a little bit. And this whole thing represents n, so n minus this 3. And what expression would represent this model? 3 less than a number. So obviously if I'm taking 3 away from n, then I know the expression is going to be n minus 3. Let's look at example 6. How would we write an expression to show the number c being subtracted from the sum of a and b? So let's look at that again. How would we write an expression to show the number c, so again we know we're using that variable, being subtracted from the sum of a and b? So we know we're going to have subtraction, and we know sum means that we are adding 2 numbers together. So we're going to start by writing an expression for the sum of a and b. Well, the sum of a and b either is going to look like this, a plus b, gosh, I keep making it look like 9s, or b plus a. Now, show c being subtracted from the sum. So it would look like this, a plus b minus c, or b plus a minus c. So the number c being subtracted from the sum of a and b would look like either of these. Example 7. Write an expression to show the number c minus the sum of a and b. So notice that's different. Now we have the number c minus the sum of a and b. So I'm going to put c minus. Now if I have the sum of a and b, I'm going to need to put that a plus b in parentheses. So let's ask, why are parentheses necessary in this example and not the others? So why would it be necessary that I have parentheses around this a and b? I want you to think about that for a minute. Why are they necessary here, but they were not necessary up in this expression? Well, the reason the parentheses are necessary is if I did not have them, so without the parentheses. So if I had not put the parentheses, without the parentheses, only a is being taken away from c. But the expression states a plus b should be taken away from c. So if I had not had the parentheses here, then I would first do c minus a and then add b. And that's not what my expression says. The expression says c minus the sum of a and b. So a plus b has to be in parentheses. Replace the variables with numbers to see if C minus A plus B is the same as C minus A plus B. So now we get to add some numbers into C. So let's say that A is going to equal 1, B is going to equal 2, and C is going to equal 3. So what we do is we just replace the letters with those numbers. So if I have C minus A plus B, I'm going to replace the numbers. I'm going to put 3 minus, my A is 1, plus my B is 2. So all I did was replace C minus A plus B with these numbers that we decided we were going to replace the variables with. So 1 plus 2 is 3. So I would do that first, my parentheses first. And then 3 minus 3 is 0. So the answer to that expression is 0. So now if I have C minus A plus B, and again I replace A is 1, B is 2, C is 3. I have 3 minus 1 plus 2. So 3 minus 1 would be what I would do first in this expression, because I always work left to right. So 3 minus 1 is 2, plus 2 is 4. So I did not come up with the same answer. So I want to make sure always that I understand when they're giving me an expression like this in words and asking me to write it, that if those parentheses are there, I need to use them. So exercise 1. Write an expression to show the sum of 7 and 15. 7 and 1 and 5/10. I missed that decimal there. So write an expression. So we're not asking you, they're not asking us to solve it. They're just asking us to write the expression. So the sum of 7 and 1 and 5/10 would look like this. 7 plus 1 and 5/10, or, okay, that says 1 and 1500. So sorry about that. 7 plus 1 and 5/10, or 1 and 5/10 plus 7. Write an expression to show the sum of 7 and 1 and 5/10, and this is what it would look like. 7 plus 1 and 5/10, or 1 and 5/10 plus 7. Let's look at exercise 2. Write 2 expressions to show W increased by 4. Then draw models to prove that both expressions represent the same thing. So write 2 expressions to show W increased by 4. So we would have W plus 4, because increased by means we're adding, or 4 plus W. If we're going to draw a model to show that, it would just be those bar diagrams. And we would show a bar diagram like this that would have a W and then a 4. And then we would show another bar diagram the same size that would show a 4 and then a W. Number 3, write an expression to show the sum of A, B, and C. Well, there are going to be several different answers, or possibilities, I should say, for writing an expression to show the sum of A, B, and C, because the commutative property says that we can add them in any way. So I want you to try to write all the ways that you could show the sum of A, B, and C, not the models, the expressions. Pause the video and then come back and check number 3. Okay, you should have had 6 possible ways to write that expression. A plus B plus C, A plus C plus B, B plus C plus A, B plus A plus C, C plus B plus A, and C plus A plus B. Now I'd like for you to do numbers 4 as a must, number 5. So 4 and 5 are both musts, writing those expressions. Number 6 is a must. Number 7 is a must. Pay attention to that decreased by. Think about what that means. And then also number 8. So once you have finished those, then bring your book up to me or raise your hand and I'll come to see it. And then I will hand you the problem set.